I'm not much for introductions. My name's Noah Dunn. If you've met me, I'm sorry. If you haven't met me, the doors are open for the rest of the talk, so you can, make that. I like doing a couple survey questions just because I'm really curious. If you are not from the United States, can you raise your hand, please? Wow, that's really cool. If you are not an engineer, could you raise your hand, please? Okay, super. Oh, yeah, here. Better? Good? Cool. Yeah, that's my stat sheet. I'm not one for introductions, so let's just get into content. Um, yeah, so really, I wanted to present this talk because I interact with threat intelligence a lot. I interact with researchers a lot. I'm an engineer, but I still work closely with researchers, and a lot of my work is based on research. So I think it's kind of cool when the engineering side of the house gets to see the researcher side of the house and vice versa. So I hope you guys gain some insight in this. That's my goal anyway. So I service two groups of people. One of them is threat intelligence, and they're kind of our researchers, or what you guys would call our researchers. They do the deep dives into these threat actors, into malware samples, into that kind of analysis, and they try to come up with some conclusions on what's going on out in the world. We also have our incident responders, and when someone gets popped with ransomware, say grandma downloads the wrong thing and gets broken into, those guys go and guys and gals resolve those particular issues. And so we have kind of the problem statement. The reason why this initiative started to begin with was incident response stores stuff in a way that is not really conducive to threat intelligence and helping them out in a meaningful way. And what I mean by that is we have this is my understanding, my loose understanding of what threat intelligence does. And if you look at these bottom 2 points in particular, they're really obsessed with accurate and concise data. So if they try to attribute a certain group with certain behavior, they want to be very sure that they're right. They don't like making mistakes. They want to be sure this is exactly what we think is happening. And they're very, very concerned with data quality and data integrity. Our IR folks, on the other hand, while they are very much on the boat of accuracy, they don't necessarily have, in all cases, the domain knowledge to know what's relevant, what's not relevant, what do we keep, what do we throw out, right? So their perspective, they're like, we need grandma's meatloaf recipe. I'm going to throw 15 shell scripts into the spreadsheet. They will give you everything and more. The problem with that is, quite frankly, our incident response, when they throw all this in, our threat intelligence folks don't have the time to filter all that out. If you get handed 15 spreadsheets and they all have huge undiscernible blobs of data, people don't want to go through and crawl through that. I wouldn't either. And so this kind of brings us to my engineering solution, one of the approaches that I built out to try to resolve this particular issue, which I call the two-phase identification solution. It's just a bunch of jarble to say this is my proposal. And before we dive into the solution itself, I like to clear terms up. I like things spelled out for me because I'm not very bright, so I like to write definitions out. When we say fanging IOCs for the sake of this discussion, what we mean is we're going to put the IOCs in a way that makes them dangerous. So like for URLs, what will often happen is folks will put extra characters in, so it's not a URL that you can just click on randomly and trigger and activate some malware or whatever. That's what we're going to call fanging IOCs. And then defanging is any process we do to prevent people from making these IOCs clickable. So anything that, injecting a couple extra characters, appending some stuff to the end that just looks wrong, whatever the pattern is, these are the terms we're going to use for the sake of this discussion. So, in general, the philosophy that I adopted and seemed to work for us and works for our particular pipelines is we like to ingest defanged and export fanged. So our IR consultants, they like to defang data because, again, if you're working in a spreadsheet and your spreadsheet has URLs and those URLs are nasty, you don't want to accidentally be clicking on that, right? But for the sake of data processing engines, like things where we're actually doing the research and don't have those, clickable objects per se, we like to export fanged because that's the real true indicator and that's what we're actually looking for, right? So I built up this diagram, and note for the sake of this discussion, like this middle part's actually what we're going to be talking about. The import and export are kind of agnostic for the sake of this. So you can swap these out for whatever. Show of hands real quick. Anybody familiar with Synapse? It's a threat intelligence platform. Anybody use it before? Cool, a couple people. Awesome. It doesn't matter for the sake of this discussion, but it's just what we choose to use, so I just felt like putting it in here. But again, this is agnostic. We're actually focused on this piece. And our total goal, like for this whole effort, this whole process, is by the end, we should be able to take in spreadsheet data, indicators that look like this, right? And we want to output them into whatever our export is. And this is, again, Synapse, and this is a Google Sheet, but really you can swap these out for whatever you choose, right? So this is, again, I'm isolating out the two-phase identification solution. We start out with, let's just say www. We have brackets, fake.com. We have the fanging indicators phase, which I'm going to present to you in a minute. We've appended the HTTP onto it. Then we type it out. And so our goal output is to get the full URL and then typing as a URL to identify, hey, this is a URL, because the objective of this is we're given no context, so we want to kind of build context based on how the text looks, the raw text looks. So the first phase, which is represented by that bat logo in the previous slide, we need to do the pre-processing of these indicators. They're largely focused on URLs because, as it turns out, it's really hard when you get raw data in to distinguish between domains, URLs with ports, URLs without ports, file path, like all these things actually complicate most data ingestion engines. And so we actually have to do quite a bit of work to get these into a good place for most tools that we would export to, which is why we do all this processing. The first step, though, is we need to fang those indicators, like I said before. And some of these steps seem trivial. We convert to lowercase. You can do uppercase if you're a psychopath. I'm not. I like looking at lowercase text. That's just me. You want to strip those leading and trailing control characters. Sometimes we have folks that use Windows, right? Sometimes we have folks that use Mac. They all have different control characters. They're annoying as heck. We want to get rid of those. If you guys really like potentially breaching data contracts and stuff, you can leave all your customer information in. We don't choose to do that at Unit 42 most of the time, wink. But you can make a big ban list and you say, don't include this data, don't include this data, don't include this data. And then you want to remove all your bracket spaces and wildcards. So that would be things like asterisks and anything else that is a pretty common one. Asterisk is the most common one in our company, so we tend to remove those guys. And then once we have all four of these initial steps, we have a lot of pretty popular scheme patterns that people use to defang. So HXXP for HTTP and HXXXP for HTTPS. Those are both pretty common at our company, so we process those. The second step seems a little bit convoluted, but really if you just look at it, all we're doing here is checking to see if we need to add extra material to domains or IPs that have ports. And these examples are actually the most useful part of this diagram, because when we get just an IP and a port, we don't have context for what protocol or scheme that might use. So in our case, we just choose to append this unknown thing. You can append whatever you want, but that's just the convention we like to use. Or sometimes, you get an IP address and someone, again, obfuscates it by throwing a bunch of garbage on the end. So we just pull out this using a regex pattern, which is represented right here. And then in another case, right, so we have a domain with a port. We don't know what application is running necessarily. So again, we can process this using that unknown tag or whatever your choice is. And that's what's represented here by this flow chart. We check a regex. We check if it's a valid domain. You can do that either with a regex or you can use a library. This is an agnostic approach. I did this in Python, but really you can pick your favorite language. And then we check IPv4 regex and check and see if we need to pull that IP out. Cool. So this one I put URL parse in here, again, Python convention. Really, most of the built-in URL libraries for most modern languages, I'm caveating that just because someone will find an exception. They tend to be pretty good. And in our case, we actually observed a lot of indicators that had this strange format. So people would use the IP port combination, and then they would also have a dash and then the file name, right? That's not really conducive. And really when we started doing some additional research, we found out that actually that was just their obfuscation for defanging. So this is just another defanging step that the initial thing doesn't catch. We have to keep dashes in from the initial defang step because, file names, URLs, like a bunch of other things. It's a legal character, but in this specific context, we want to use a regex in order to change that out because we want to include these indicators. We don't just want to throw them out. And really one of the goals of this whole process is to maximize the number of indicators we actually get out of, Pop-Tart garbage data, whatever you want to call it. We want to be able to get as much out as we can. So a lot of URLs that look like this is a URL, but it doesn't have a scheme. And sometimes this will be stored like this, and we want to capture this as a URL, but it isn't, in its current place, it's not a valid URL. So what we do in our processing is we append HTTP to it, and then we check it and see, okay, is this a valid URL or not? If it is, we add it to our URL list. If not, we keep going. And so that's kind of the summary of all four of those guys. And that's all the pre-processing, that's all the fanging of the defanged indicators. That is stage one of that whole process. And there's the summary up there of essentially what that leads to. Now, we've defanged everything, so we should have all of our IOCs in a place that look good enough to use for the sake of the rest of the processing. Now we need to try to identify what they are. And I looked for a long time, at least in Python, and for some reason, if you just give raw text to a lot of these libraries, there's no library that I could find that exists that just says, hey, here's raw text, guess what this this piece of text is, indicator-wise. I could not find it, which is part of the reason this talk exists, right? And so the approach that I found that worked the best for me was that I took the most consistent patterns, like the most predictable IOCs, and went from top to bottom into the least predictable IOCs to try to figure out what was going on. If you guys are familiar with a sieve, it's used in archaeology and also like baking, right? You take these big chunks and you shake it, and the big pieces stay at the top and the little pieces keep moving in the lower layers. That's essentially what this process is. We take those big, easy to get ones and we keep sifting it down until we get to the more minute pieces. If anybody wants to do I don't know if anybody knows what worldstar.com was, but it was essentially this website back in the US that when people were fighting in the street, kids would take their phones out and yell WardStar. And for some reason, every time I see somebody at this conference taking a picture of the slides, that's all I can think about is WorldStar. So all I can think about is, so if you were going to do your WorldStar picture, the one slide you should capture on your phone for the sake of this discussion, this is the slide you would want to take a picture of. But it'll be up in the end. Again, this is the order of all the IOCs and the way that I process them from easiest to hardest. And it's not even necessarily easiest to hardest because some of these last ones have really rudimentary processings. It's just by the time that we get done catching all these guys, what's left that isn't easily identified as garbage is more than likely something down here. And so we can use more trivial approaches to try to gather it. So this is just going to walk through all of these different IOCs. So first, guys, IP addresses. There's a lot of built-in libraries. If you don't like libraries, you can use a regex. So this first step says, does a library believe? You can use a regex if you so choose. And essentially, if the regex or library says it's IPv4, we go down here, and I'll explain this in a sec. But if it doesn't, and it says it's an IPv6 and it matches the pattern, it's an IPv6. Easy. They're pretty concretely defined, right? For some reason, and I found this to be true in a couple Python libraries, they treat IP and port combinations as IPs, but if you're actually looking for a pure IP address, that's not valid. So you should check to see, is there a colon in it? And if there isn't, then it's an IPv4. Otherwise, it might be IP and port combination. This is a super easy way to check for hashes. You might be like, no, that's really dumb. Why did you do this seemingly stupid approach? And as it turned out, in our particular data set, which is pretty large, this actually works, and we didn't have any false positives come up. So you can actually just check the length of the string and then try to convert it to hexadecimal. And if that works, then it's either MD5, SHA-1, or SHA-256, depending on size. Again, it seems really dumb, but it works. And for our purposes, it did exactly what we needed it to do. So domain names are also kind of nasty because, as it turns out, there's domain names like .py now, which really frustrate me personally because that should be illegal. But you can have main.py, which is a Python file, but you can have www.main.py, and that's a totally valid domain, and neither here nor there, but I'm kind of upset about that particular decision. Not a fan. Anyway, a way to get around that in order to dribble down into the lower levels of the processing is you just put a like master list of all the TLDs that you like and all the ones that are acceptable, and then you remove the ones that are problematic for you. So if you see a lot of Python files, you might want to remove .py, or if you see, what's the other one? There's a country I can't think of right now that has an ending that is also, I can't think of it, but maybe it's .pl is like Prolog files. You know, people writing malware in Prolog or whatever. Yeah, go nuts, but you remove those guys. So, I'm sorry? Yeah, yep, you're right on the money. URL validators, like I said earlier, they're actually pretty good. At least the libraries I mess with, so you can actually usually trust them. Again, I'm not going to caveat all cases here, but in our instances, the URL validators work perfectly fine. So we just use the library for this. Technically, you can use a really long regex too. They look fine. When I tested them, they looked fine too. I ended up using a library because URL parse did the job. Email is best done with a regex because they're pretty straightforward. However, we found that some regexes and some libraries, weirdly enough, would allow certain email addresses that did not have an @ symbol. I don't understand why. I think it's a pretty significant bug, but again, something to consider. And the dot, again, I really couldn't tell you why, but we do this as a preliminary check just to make sure. Host names, this one is actually super up to interpretation. So a host name is like a Windows or a Linux box name. We have, in our particular data, a series of host names we know that appear a lot. Like, for example, some Windows boxes will be named, in a lot of cases, especially with some VM software, they'll start with WIN for a Windows box, right? That's a pretty common prepended thing. You can write a big list of things that you see a lot and then just check and see if that is located, and maybe it's all capital letters containing hyphens with that, right? Ours was pretty simple, again, based on our data that we found to be the most common and the things that we saw happening a lot. So user agents, I put this for brevity. I didn't put the whole thing, but I'm sure any of you that have analyzed user agents before know that they have like these really long, nasty chain of like 180 characters. If you put, like Chromium dash and then whatever the prepended or appended text is, you can catch pretty much all your user agents. And keep in mind, we're like 6 or 7 steps deep at this point. The stuff that's left is either pure garbage or it's one of these last couple types. So we're starting to narrow down the number of available options we have left. File names and file paths are an absolute pain in the butt. And there's no way around that because they look like domain names. And again, .py exists. Like, there's really no easy way to say it other than they're an absolute pain to deal with. There's Linux file paths, which are different than Windows file paths, which are kind of different from Mac file. Like, it's a nightmare. And also, a lot of people love to defang with backslashes, which is used in some other IOCs legitimately, which makes it even more fun. So what we chose to do is that we replaced all our backslashes with forward slashes, and then we used a really, I don't want to say rudimentary because it actually is fairly complicated, but a file name regex. And keep in mind, we already parsed out all the TLDs we didn't like. And we checked to see if it matched our file name regex. So that can be something as simple as any letter numeric dot any letter numeric as a valid file path. You can do something as simple as that. You can make it more complicated if you usually see a certain file extensions. You can include a whitelist of all the ones you like .exe, .py, so on and so forth. And then if it isn't a file name, again, remember by this point we've gone through like pretty much every other IOC other than garbage, PowerShell scripts, your mom's meatloaf recipe, whatever. Like, we've gone through pretty much everything else. So we can check using a lot of libraries. There actually is a couple good ones in Python. They're still not to my standard because honestly I think a lot of them are garbage, but they work good enough to check and see if it's a Linux path, a Windows file path, a Mac file path, etc. And then we can outline those as file names and file paths. Cool. Probably the most important thing of this whole process, and I just provided this Python code sample, but honestly anything works here, is you want to log the ones that don't catch with anything because they have to be something really crazy or you messed your code up. In my case, I messed my code up a lot. So I had a lot of mistakes along the way, and this caught a lot of it. But the cool part about this is if you have a threat intelligence team or something to that effect, you can send off all the list of indicators that were not captured correctly, and you can say, hey, do any of these look valid? Yes or no? And then, maybe we went from, let's just say, 100,000 indicators down to a set of 1,000 that aren't captured. Your TI is not going to want to go through 100,000 indicators, but 1,000 is a little more manageable. And ideally, I think in our case, like by the time everything was said and done and all the procedures were in, I think we only ended up with a set of maybe 60 or 70 that were problematic, and that's a lot more manageable to go through. So there again, there's your world star shot. Everybody take a pic, selfie, whatever. There's your IOC order of operations. And if you're curious, like, okay, are there things that I can add in here or swap out? Yeah, I mean, depending on your use case, like maybe you see a lot of file names and you see hardly any IPs. Why that would be the case, I have no idea. But let's just say, for example, right? In order to make your code run faster, you can just move this block up here and then it'll terminate a lot earlier and you get better performance out of it. Vice versa with any of these, you can swap any of these out. So there's my little sieve visual from earlier, but yeah, we're taking those big objects, like I said before, we're sifting them down, smaller objects, into the easier parse stuff, top to bottom, and we log the ones that are unknown, which is honestly the most important part to make sure that you're actually doing things right and that you're getting TI the data that they need. And yeah, at this point, whatever your preferred platform is, whether it's Sticks, whether it's Synapse, whether, pick your favorite export format. At this point, you now know your indicator in a cleaned up format and you know your type, so you can export it to whatever your platform is of choice. For us, again, that starts with G Sheets and then goes to Synapse, but for you, it may be something much different. And there's, again, the overview. So again, just to recap, we fang all the indicators, we reverse using the known defanging patterns that we already established, and we prepare it using that pre-processing we already did. And then we run it through the IOC orders operations. And another kicker here is, again, that's just the logging bit. So unknown or whatever you want to call it, invalid, whatever. And then, again, using that information, it may be your choice to just leave those as invalid, right? So like in our data, I'm not joking about like mom's meatloaf recipe. Like we see some crazy stuff that comes across our spreadsheets that people just throw in because they don't know if it's useful. Most of the time it's not, but all it takes is one to be valuable to, justify it. So you might just want to leave those out, or you might want to create a new data type, or, you might just want to send that off to somebody else to manually investigate. So in terms of performance, because I'm an optimization nut, I'm really obsessed with performance and output and all that geeky stuff. Our initial set, which I wrote in an all-night bender, was at 47.8% capture rate, which is trash, to be quite frank with you. But again, I wrote it overnight on like no sleep. And the final product, which took a much longer time but was worth it, actually yielded us 99.8% capture rate, which I was pretty happy about. And overall, we were able to ingest even more stuff because of some additional modifications I made. So total, we were able to get another 410% in, which has since helped our TI be able to do additional research and link, different threat actors together, so on and so forth. And we've had a few false positives reported. Again, really, really weird out there things like consultants putting in data in a pretty strange way. And don't get me wrong, I don't blame the consultants at all. They do a very hard job, and they're not concerned with, again, what attribution, what actor is. They want to triage, they want to get people the response they need, they want to get people help, and they capture the data and then send everything back to the client. That way later on we can take a look at it. I'm not blaming them in any way. Part of my job is to make everybody else's jobs easier. So that's why I'm employed. So if you wanted to optimize this even more, you could create some like really complex IOC rules. So bash, PowerShell scripts, like really long strings that are annoying. That'd be kind of cool. And really, I think this first point is kind of the most important. You want to identify the most high demand IOCs because you want to make sure that those guys are the ones that are captured effectively, efficiently, and accurately. And like I said earlier, you can change the inputs and outputs. You can add or subtract IOCs to fit your needs. Here's a big long list of lessons learned because I think that's really important when you do a big project, because this took me quite a while to get done, but I'm glad I did it. And I think the last two are actually the most important points here. Don't pull all-nighters to do crazy work, and work on cool projects so you can go to Ireland for a week. Just speaking frankly. So questions from anybody?